Hello, my name is Mackenzie Maxwell, and this is my first physics lab on constant velocity. The goal of this lab was to analyze an object moving constant velocity in a manner similar to that of an ideal world. This included a position versus time graph using a tracker model, and also included a glow script model that outlined the ideal world. I then compared both outcomes. I recorded a jar rolling with constant speed across the table using tracker, and I then created a theoretical model using glow script. This model was based off the momentum principle, the position update formula, and the fact that F net equals 0 newtons in this scenario under these specific conditions. With a comparison of these two models, the data from the tracker trial showed strong resemblance with that of the glow script trial, indicating that the object was moving close to a constant velocity. Both position versus time graph displayed a relatively constant positive slope, and constant slope for a position versus time graph indicates a constant velocity. This is the original video. And this is the video with tracker analysis. As you can see, the scaling factor for this trial is between the coffee cup and the white strip of paper, which is around 1.5 meters. The jar moves from left to right on a positive position axis. The position of the jar is recorded at 24 intervals depending on each frame of the video. Each tracker pin is in the center of the lid, and this jar was recorded immediately after the jar enters the view, which is a short time after the jar is in no contact with the hand. According to the position versus time graph, the jar moves at a constant velocity throughout the recording, as you can see from this relatively straight slope / constant slope of the position versus time graph. And down here is the stats from the trial. These are the scientific principles of this model. The model represents the world in some ideal conditions. Since the force of gravity equals the force of normal and there are no other forces acting in the jar, both forces cancel out, meaning F net equals 0. The momentum principle is also used, where the final velocity equals the initial velocity plus F net over m times delta t. It is possible to approximate the final velocity with this formula. Since F net equals 0, the final velocity will be the same as the initial velocity, denoting constant velocity. The position update formula is similar. The position update formula predicts the location of a jar undergoing a certain average or instantaneous velocity. In this case, we use the former to track the jar undergoing constant velocity motion. Now, at this point of the lab, the glow script model was used as a comparison for the tracker model. The glow script model shows how an object would move in a perfect world while taking into account specifications of the object in question. The values from the original video analysis include initial position, where only the x is being used because there is no y or z values, initial velocity, and the duration of movement. Also including the known principal formula and the position update formula in the code. After the program is run, the program prints out the time position values for each step and is specified in the code. As you can see to the right, there's a sample of these numbers that it shoots out. As you can see, the velocity versus time shows a straight line indicating constant velocity, as well as the position versus time being constant slope also indicates constant velocity. For the conclusions, the tracker data and the glow script model display a very strong resemblance, and due to the strong resemblance, it can be concluded the jar moved extremely close to a constant velocity. The strong resemblance also indicates limited error. As you can see on the Excel graph to the right, they both move at a constant velocity, at a very similar constant velocity, as well as there is limited error between the straight line of glow script model and the data points of the original. There could be sources of error by sense of friction. Since the jar was used, there's more surface area and contact with the table at any given time, which could have increased static friction, as well as the surface of the table was not entirely smooth, which could have also increased static friction, and there also could have been human error. Possible improvements could be using a ball on a smoother surface to reduce friction, and also using a better method for calibration. If the time and the position axis were to be flipped, the graph would not change, as time would be increasing on the now y-axis while position would be increasing on the x-axis. Those results clearly indicate a direct relationship between time and position, and its relatively constant slope indicated its constant velocity. Simply flipping the axis from one to another would not change the direct relationship to that of inverse or any other. In other words, the relationship would not change from direct. In a perfect world, since we know the jar is moving at a constant velocity, there are no other forces in the x direction acting in the jar other than that of the force of gravity. The force of gravity is cancelled out by the normal force, the force the jar exerts back on the Earth, so we can say that F net equals 0. However, since this case occurred in a non-ideal world where friction is not negligible, forces of friction, like air resistance or static friction, would indicate an F net in the opposite direction of motion. Thank you for listening.